طيب بسم الله والحمد لله والصلاة والسلام على رسول الله وعلى آله وصحبه وله. Any questions يا شباب before we proceed? Any questions before we proceed? Okay. طيب, so what did we do last Thursday? We basically looked at the pigeonhole principle, and we saw some interesting examples of how the pigeonhole principle or the generalized pigeonhole principle can be used to prove interesting results. So today, inshallah, we will only take kind of the last two examples of using the pigeonhole principle, and then we will move on to section 3, 6.3. طيب. So let's start with this example. So assume that in a group of 6 people, each pair of individuals consists of 2 friends or 2 enemies. So basically what we have here is we have 6 people, and if you choose any pair, you can classify them as either friends or enemies. What is the question? The question is, show that there are either 3 mutual friends or 3 mutual enemies in the group. So we want to show that there are 3 mutual friends. ايش يعني 3 mutual friends؟ يعني the 3 people, each pair is basically a friend. صح؟ أو 3 mutual enemies, 3 people, each pair is an enemy. Okay? This is what we want to show. طيب. So how are we going to do that? Well, let us first let's look at like one of the 6 people arbitrarily, okay? And let's give it a label. Let's call that person A, okay? So let A be one such person. Let A be one such person. Now, what is the relationship between A and the rest 5 people? They can be friend or enemy, صح? So A can be a friend or an enemy of the rest of each, صح? Of each of the rest 5 people. Okay? Each of the rest of the rest 5 people. Okay? طيب. So now, does the generalized pigeonhole principle give us any information about this person and the rest 5 people? In other words, how can anybody see boxes and objects in this scenario, in this situation? Yes, go ahead.
It can be friends of 3 and enemy.
Where did you get the 3? You're right, but so let's go back a little bit. Boxes will objects. Does anybody see any boxes or objects here in this situation? Go ahead.
Everyone have enemies and friends.
So enemies and friends are what?
The boxes.
The boxes, right? The K is enemies and friends. طيب, والobjects, مين هم الobjects? The 5 people, صح? So based on that, so using the generalized pigeonhole principle, using the generalized pigeonhole principle, Yalla, what do we conclude using the generalized pigeonhole principle? We have 5 people, and each one of them can be either a friend or an enemy of A, صح? So what does the generalized pigeonhole principle give us?
At least one will be, two of them will be individual.
At least how many?
Either three.
At least one.
3. مالكم يا شباب؟
Five.
مش قلنا ceiling of ال n over k صح؟ We have 5. Each one of them is either friend or enemy. So the ceiling of 5 over 2. So we know for sure that we have either 3 friends with A or 3 enemies with A. صح ولا لا? So using the generalized pigeonhole principle, we know that there are at least 3 friends with A, or at least 3 enemies with A. Okay, so let's take case 1. If A has at least 3 friends. If A has at least 3 friends, let's say these friends are whom? Let's say B, C, and D. شو رايكم?
Okay.
Let's assume that A has at least 3 friends, namely B, C, and D. طيب. If that's the case, what do we know about the relationship between the B with C with D?
You can be friends.
Friends or enemies, صح? طيب. What happens if one pair from B و C و D are friends?
All of them is friends. Three.
مين هم ال 3? For example, so without loss of generality, assume that B and C are friends. Okay, between brackets, i.e., we have at least one pair of friends. Then we are done, صح?
Yes.
Then A, B, and C are mutual إيش؟ are mutual friends. طيب وإيش الكيس الثانية؟
B or C are enemies.
لا. احنا ايش قلنا؟ قلنا that is we have at least one pair of friends. In fact, maybe I should have started actually with this one. That assume that we have at least one pair of friends, namely B and C مثلا. طيب ايش النيجيشن ل we have at least one pair of friends؟
We have more pair.
Hmm?
One pair of enemies. We have no friends.
We have more
We have 0 pairs of friends, صح؟ وايش يعني we have 0 pairs of friends؟
enemies.
They are all enemies. مش صار في عندنا 3 mutual enemies؟
B, C.
البي والسي والدي. Okay, so instead of A, B, C being our solution, 3 mutual friends, our solution will become what? Will become B, C, D, because now we have 3 mutual enemies, right? Otherwise, B, C, and D are mutual enemies. which means that we are done, صح? So in both cases, we are done. If at least one of the pairs is a friend, then with A, I will have 3 mutual friends. If none of the pairs is a friend, then all are enemies, so I have 3 mutual enemies. طيب, case 2. A has at least 3 enemies. Is it going to be different from the previous case? It's going to be exactly the same. I'm just going to replace friend with enemy or enemy with friend. Bas. Right? So A has at least 3 enemies. The same line of argument holds. So there is really no need to rewrite it. Okay? There is no need to rewrite it. واضح يا شباب? Any question? طيب. So as we can see here, we have used the generalized pigeonhole principle to show that in any group of 6 people where each pair is either a friend or an enemy, we have either 3 mutual friends or 3 mutual enemies. طيب. Let's take another application of the pigeonhole principle, and here we will not see it really directly because it's actually related to the proof of the theorem. And to tell you the truth, we're not going to look at the proof of the theorem. Okay? So let's just look at the theorem and apply it. What does the theorem say? The theorem says every sequence of n squared plus 1 distinct real numbers contains a subsequence of length n plus 1. That is either strictly increasing or strictly decreasing. طيب. Let me first clarify what do we mean by a subsequence. So let's consider this sequence here: 8, 11, 9, 1, 4, 6, 12, 10, 5, 7. What do we mean by a subsequence?
1, 4, 6.
1, 4, 6. طيب, what about 1, 6, 7?
1, 6, 7. That's not a sequence.
No, it is a subsequence. It is a subsequence. So this is different from, the notion of a string and substring. In the notion of a string and a substring, if I have a substring, the position of the characters in the substring, they have to be after each other, صح? If I start my substring at position, let's say 3, then the next character should be the 4th in the original string. And the next one should be the 5th in the original string, صح?
Yes.
Well, this is called a substring. But a subsequence, it's basically, we are getting, the only restriction that we have is if I have, let's do it here. So let's say I have, I, 1, 2, 3, 4, until, let's say, n. Okay? So we have n elements in my sequence. طيب, what are the shapes of my subsequences from this sequence? Well, they are of the following form. They are of the form, J1, J2, JK, where J1 is strictly less than J2, strictly less than J3, strictly less than JK.
The element or the position?
This is the position. This is the position.
String.
واضح؟
String.
No, sequence. Sequence. And مثلا, if you have A1, A2, up to AN. What is a subsequence of A1, A2, up to AN? Well, we can have AJ1, AJ2, AJ3 مثلا. What's the relationship between those indices, J1 والJ2 والJ3? إنه J1 is less than J2, less than J3. It should not be the case that J2 is equal J1 plus 1 والJ3 is equal J2 plus 1. واضح يا شباب? So now if we go back here, is, what was my example? 167. Is it a subsequence? Yes. طيب, what about 12, 5, 10? No, it's not a subsequence. Why? Because we have 12 is okay, 5 is okay. Now 10, well, 10 should come after the 5. 10 هنا اجت قبل ال 5. Okay? So this is what we mean by a subsequence. واضح يا شباب ال definition تبع subsequence? Yes. ايش هي? One element, of course. Yeah, if you have one element, it is a subsequence. Okay? طيب. So now, what does the theorem say? If I have n squared plus 1 distinct real numbers, then I have a subsequence that is strictly increasing or strictly decreasing of size how much? At least n plus 1. Or n plus 1, let's say. Okay, I have to have a subsequence that is strictly increasing or strictly decreasing of size n plus 1. Okay, so for example, can we apply the theorem on this subsequence? How many distinct real numbers do we have here? 10, صح? 10, which is what? Which is the 3 squared plus 1, right? So what does the theorem imply?
3 plus 1.
So it implies, oops, نستخدم الأخضر. It implies that we should have 3 plus 1, which is equal to 4. We should have, خلينا نقول أول شيء, a subsequence. A subsequence of length 3 plus 1, which is equal to 4. طبعا من وين اجت 3 plus 1? انه my original sequence was of length was consisting of 3 square plus 1 distinct numbers, صح? Distinct numbers. So it implies that we should have a subsequence of length 4 that is strictly increasing or strictly decreasing. Okay? So now, who can tell me, who can propose a strictly increasing subsequence of maximal length from this sequence? Also, yes, maximum, يعني the highest that we can get. Okay? The maximum number of elements. وكمان بدنا strictly decreasing. يلا وين ال strictly increasing؟ هاتوا لنشوف. Yes. 1 4 6 12 صح؟ 1 4 6 12. So this is of length 4, which is in line with the theorem, صح? Do we have more than 4? Can anybody come up with a subsequence that is strictly increasing with more than 4 elements?
And the sequence is given.
Yes, in the given sequence. I don't think so. طب, can anybody give me another subsequence of length 4? Go ahead.
1 4 6.
Also 1 4 6 10 صح؟ 1 4 6 10. So we what about 1 4 5 7?
1 4 5 7.
1
Yes.
4 5 7. All these are subsequences of strictly increasing numbers of length 4. طيب, who's going to get me a strictly decreasing subsequence of maximum length? Go ahead.
11,
11,
9, 5, 7.
9, 5, 7.
6, 5. 6,
5 7 ما بتزبط لأنه صح؟
5.
So 11 9 6 5. 11 9 6 5. طيب anybody can give me another one? Go ahead.
11, 9, 1, 4. 4, okay. No, it's not length 4.
I need length 4. Yes.
12, 10, 5.
بطلت؟ في واحدة تانية يا شباب of length 4؟ ترى it doesn't seem like there is another one of length 4. It doesn't seem like that there is another one of length 4. So this is how we can apply this theorem. And where do we use the pigeonhole principle? It's actually in the proof of the theorem, which we will skip. Yes.
What if the origin sequence was 1, 4, 5, 6, 7, 8, 9, 10, 11, 12?
طيب. So what does the theorem say? There is at least a subsequence of length 4 صح? That is increasing أو decreasing.
Is it at least or exactly?
No مش كيف exactly؟ هي لقينا أكثر من وحدة هنا of length 4 صح؟
No, I mean the length. The length would be n plus 1, 5.
N plus 1. Yeah, but does it mean you cannot find more than n plus 1? No, it guarantees you have a subsequence of length n plus 1.
Okay.
If you have, for example, as you mentioned, if the sequence was all increasing, صح?
Yes.
Does it have a subsequence of length 4 which is strictly increasing or strictly decreasing? Of course, it has. It has more كمان.
It doesn't have decreasing, right?
It doesn't have. هي الثيورم ايش بتقول؟
Yeah,
بتقول or مش and.
Oh,
The theorem says or. Okay?
okay.
تمام؟ طيب. So let's move on now to chapter 3 where we look at permutations and combinations. Now, notice here that many counting problems can be solved by finding the number of ways to arrange a specified number of distinct elements of a set of a particular size where the order of these elements matters. And in some other problems, in some other counting problems, they can be solved by finding the number of ways to select a particular number of elements from a set of particular size where the order of elements selected does not matter. Now, who is going to determine that? Well, the question. The question and subsequently you. Okay? You have to figure out whether the question requires that, objects are ordered in a certain order, meaning order matters or order does not matter. So, for example, the question, in how many ways can we select 3 students from a group of 5 students to stand in line for a picture? To stand in line for a picture. Order matters or does not matter? Does not matter? ليش does not matter? You are taking a picture where you are standing in line. If you have the same 3 people, you are one of them. In one picture, you sit, to the left, or you stand on the left. In the second one, you stand in the middle. On the third, you get exactly the same picture.
No.
So order matters.
نفس الصورة نفس الأشخاص.
نفس الأشخاص بس الصورة مختلفة. الصور مختلفة. صح? So in this case, order matters. Whereas on the other hand, if the question was how many different committees of 3 students can be formed from a group of 4 students?
Okay. Does not matter.
Now, does it matter the order, how you choose the 3 students? It doesn't. So here, order does not matter. Unless, of course, unless, for example, if you say that the committee has a chairman, a secretary, and a treasurer. So now you need to assign each student to a position, صح?
Yes.
So now order matters or does not matter?
Matter.
Well, now order matters. But here they are all members. There is no distinction between, you know, the positions of these members. So in this case, order does not matter. So let's start with permutations. So what is a permutation? Well, a permutation of a set of distinct objects in an of distinct objects is an ordered arrangement of these objects. In chapter 2, when we studied sets, did elements of the set have order?
No.
Elements of the set did not have order. So what is a permutation? Basically, a permutation, you are imposing an order on the elements of the set. Okay? طيب. What is an R permutation? Well, an ordered arrangement of R elements of a set is called an R permutation. So now, what is the difference between a permutation and an R permutation? A permutation is an ordering of the whole set, صح? Elements of the whole set. طيب, will R permutation is an ordering of only R elements of the set.
Is it a subset? R is a subset of
The R elements are a subset of the set, but then you impose an order on them.
Yes.
Okay? And then you impose an order. For example, let S equal 1, 2, 3. Can anybody give me an ordered permutation of S?
3, 2, 1.
3, 2, 1. 1, 2, 3, صح؟ يعني so for example 3, 2, 1. 1, 2, 3. 2, 3, 1. All these are ordered permutations of S.
How is it ordered? What do you find as ordered?
Ordered, هيهم. I put first 3 and then 2 and then 1.
What's unordered? Can you do it in unordered?
هيها. This is I'm telling you.
Unordered.
Unordered is when, for example, if I put them as a set, as a set 1, 2, 3, is it different from the set 2, 3, 1? Is it different from the set 3, 1, 2? It's not. But are these permutations different? The answer is yes. This permutation is different from this permutation, is different from this permutation.
لأنها بس أقواس كذا بس.
مش بس لأنها أقواس, because I'm imposing an order.
We don't care about increasing and decreasing.
We don't care about increasing, decreasing. Just the position of each element of the set. Each one of, if they are different, then they are different permutations. They are different permutations, of course, on the same set. They are different permutations on the same set. طيب, who can give me a 2 permutation of the set S?
3,
2, 3 مثلا, صح? 2, 3. ايش رأيكم 1, 3? 3, 2. All these are 2 permutations. So now the question is, how can we find the number of R permutations from a set with n elements? Okay? So the number of R permutations of a set with n elements is usually denoted by PNR. PNR. Now, let's see how we can compute it using the product rule. So what is the objective? The objective here is to do what? What are we computing? The number of R permutations, صح?
Yes.
طيب, how many positions are there to fill?
3. No. Can we have 2?
How many positions are there to fill? R, صح? So I have P1, I have P2, I have P3, all the way up to PR. And how many objects in the set do I have? Or how many elements of the set do I have? I have n, صح? So in position 1, in permutations, by the way, permutations where order matters, صح? احنا قلنا هنا order matters. How many elements are available to fill in position 1? Position 1 بس. N صح؟ This one is N. طيب in position 2 N minus 1. Position 3 طيب و position R N minus
minus 1
R minus 1 صح؟
Oh, yes.
Just look at the pattern. ال position 1 went to N. Position 2 went to N minus 1. Position 3 went to N minus 2. Every time it goes to position N minus and then 1 less. صح? So what is 1 less of R? R minus 1. هي. Which is the same as N minus R plus 1. So now what is the total number of R permutations? We need to use n factorial over ايش؟ over n minus r factorial, which is, by the way, the same as what? اللي هي n times n minus 1, because we're using the product rule. N times n minus 1 times n minus 2 all the way times n minus r plus 1. Okay, so here we come. If n is a positive integer and r is an integer with r greater than or equal to 1 less than or equal to n, then there are n minus 1 times n minus 1. من وين اجت ال n minus 1؟ There are n times n minus 1 up to n minus r plus 1 are permutations of a set with n distinct elements. طيب, Pn0, what does Pn0 represent?
0
R is 0, صح? So how many orders do I have of the empty set? It's only 1, صح? That's why Pn0 is equal to 1. And the corollary that you just mentioned is that this value here, Pnr, اللي هي n في n minus 1 all the way في n minus r plus 1, this is the same as n factorial divided by n minus r factorial. Why? Because after n minus r plus 1 ايش راح يجي؟ n minus r, صح؟ راح يجي n minus r وكل الارقام اللي قبلها اللي هي ال n minus r factorial. ف if you put n minus r factorial in the denominator, it will cancel out with n minus r factorial here, and you will get the n في n minus 1 all the way times n minus r plus 1. واضح يا شباب؟ Any question? طيب. How much should I give you? I'm not in a mood to solve. I want you to solve. Let me give you 4 minutes. ايش رايكم؟ I'll give you 4 minutes. Try to solve these 3 questions. It's actually much more than what you need. Okay? So try to solve them, and then we will solve them together. Okay? And then we will solve them together. So let me give you 4 minutes. 4 minutes. You will find it easy, inshallah, to do them. But the problem is in the exams, they will not be under, permutations, under combinations, under... I will give you the question and you have to figure out, what you should solve. صح?
example 3, is the size of R the same as M?
We'll come to it, inshallah, when we solve it, we'll see. Okay, yalla, let's go for the first one. How many ways are there to select a first prize winner, a second prize winner, and a third prize winner from 100 different people who have entered the contest?
Is 100
طيب.
and R is 3.
And R is 3, صح? So it's basically, it's going to be P 100, 3, which is what? Which is 100 multiplied by 99 multiplied by 98, which is 100 factorial divided by 97 factorial. The most important thing is you should know this one, صح? You should know this one. You will see that we are going to use all these techniques in chapter 7. Okay? We are going to use all these techniques in chapter 7. Now,
Just a random question is, in the final or in any exam, if I just leave it like this without multiplying it actually, is it enough?
if we did not specify that you should come up with the last value, I think this is enough. Okay? طيب. Okay, example 2. Suppose that a saleswoman has to visit 8 different cities. She must begin her trip in a specified city, but she can visit the other 7 cities in any order she wishes. How many possible orders can the saleswoman use when visiting these cities? Huh? 8 factorial. What do you think? 7 factorial. Why 7 factorial? Because she has to start from a specified city. She has to start from a specified city. So this city doesn't count. Okay? For example, it's starting from the city where she lives, right? So, and then she has to visit the other 7 in any way she wishes. So basically the total in this case is gonna be 7 factorial. Now, imagine if she wanted to minimize the cost of the trip. How many scenarios does she have to check?
7. 7 factorial.
7 فاكتوريال. ليش 7 فاكتوريال؟ طلعوا الآلة الحاسبة لا تستحوا. 5040. 5040. Okay, that's why, you know, this problem is not an easy problem to solve. I mean, look at this. Just with 7, look at how many scenarios you need to check. Right? This type of problems has a specific name. It's actually called the NP-complete problem in computer science. And those of you who will take ICS 353, you will study that, inshallah. Yes?
This doesn't use the P.
Why not?
How would I use it here?
7 factorial is P what?
P77.
P77. P77. Yeah. In R7, you're basically choosing a permutation of 7 cities. You're choosing a permutation of 7, and this might have answered your question, by the way, صح? So let's go now to example number 3. How many permutations of the letters A, B, C, D, E, F, G, H contain the string ABC? Go ahead.
6 factorial.
6 factorial. Why 6 factorial?
Well, you can count ABC as one letter.
You can count ABC as one letter, one big letter, صح?
Yeah.
And then?
You have the 5.
And then you have 1, 2, 3, 4, 5, 6. So, huh? ليش R1? It is also 6. In fact, one of you in the other section, this is how he looked at it. He said first, okay, I have an ABC, صح? And then what do I have? I have D, E, F, G, H, صح? So for these, how many ways do I have to order them? 5 factorial, صح? So this is position 1, position 2, position 3, position 4, position 5, because these are 5 letters. So I have 5 factorial to put them in this position. طيب, next, what do I have to do? I have to place the ABC, صح? How many positions do I have? 1, 2, 3, 4, 5, 6. So for a total of 6 multiplied by 5 factorial. مش هذا هو نفسه 6 factorial؟ عيد مرة ثانية. الآر ليش 2؟ الآر هنا 6 كمان. الآر is also 6 because you have basically one character, 2, 3, 4, 5, 6, and you want to get a permutation. So again, this is what this is stuck. It doesn't want to go away. This is again P66. 6 factorial, which is P66. Okay, Shabab?
So example 3, it's asking me to rearrange it. Is that what it means?
It's asking how many permutations of these letters contain the string ABC. So it's the same as...
ABC as ordered like this.
Exactly. You cannot have anything between A will B with C as one block, ABC. واضح يا شباب؟ Okay? طيب. So let me close the